The real economics of AI compute power, what wafers, and the illusion of the infinite sky. November 15th, November 5th, 2025. Your group realist analysis is following the early November 2025 announcement to confirm that the AI boom is real, but the timing isn't. Silicon is ready months before the gigawatts. Over the last 18 months, the semiconductor industry has been living through a generative AI gold rush, capital expenditure commitment, GPU shipment, and data center power projection are growing at rates the market hasn't seen since the dot-com or crypto mining booms. The rarest NVIDIA's GTC keynote made the scale explicit, and it's time to separate what's physically possible from the what's scalative. The GTC shockwave, 4 million hoppers, and 3 million Blackwells, and 7 million more in the pipeline. NVIDIA's GTC Washington DC 2025 keynote confirmed that what many suspected, the company's GPU engine is running at industrial scale. 4 million Hopper GPU H100 H200 class shipped across 2023 to 2025. 3 billion Blackwell and GPU already produced between Q1 2024 and Q3 2025. A pipeline of 7 billion more Blackwell and Rubin GPUs to be shipped by the end of 2026. At the same time, NVIDIA teased a total of 20 million GPU dies for 2025 to 2026, but this number is misleading. It refers to dies, not packages, since each data center GPU package integrated multiple dies. The physical shipment count in a package roughly half of that figure. In other words, 20 billion figure makes the ramp up sound even larger than it is. The translating heap into hardware, what 7 billion Blackwells Rubin really means. When we translated NVIDIA's statement into system level terms, the scale becomes easier to grasp. The 7 million SIP GPU package correspond roughly to 97,000 racks of computer system such as NVL72 or NVL4, NVL1 and 44. Assume a pure of the 1.3. This implies around 18 gigawatt of new NVIDIA AI center power capacity to be delivered by the end of 2026. For context, OpenAI is for now targeting about 26 gigawatt of total AI compute over the next 4 years, roughly 1.5 gigawatt per year, split between the 10 gigawatt of NVIDIA's GPUs, 10 gigawatt of Broadcom custom AI ASICs, and 6 gigawatt of AMD GPUs. Some of these announcements likely overlapped with the Stargate project, the 10 gigawatt, $500 billion AI infrastructure program with Oracle and SoftBank. According to an official letter from OpenAI Chief Global Affairs Officer, roughly 7 gigawatt of the capacity is already planned for development over the next 3 years. But of course, it does stop there. OpenAI has committed to the renting $250 billion worth of compute from Microsoft Azure and uh, $38 billion from AWS and has signed multi-billion dollar deals with CoreWeave. And that's just OpenAI, the last of the hyperscaler, neocloud, and model training ecosystem, including xAI, Anthropic, Mistral, CoreWeave, Google, AWS, Microsoft, Meta, Oracle, and others, is stacked on top of this demand. OpenAI suggested that the US should double its annual power deployment from roughly 50 gigawatt today to around 100 gigawatt per year to sustain the next wave of the AI infrastructure growth. The numbers are unprecedented, and the physics are starting to bite. Supply chain stretch to its limit, wafer and power to reality check. The semiconductor industry loves volume labs, but can logic wafers, CoWoS package, and HBM memory and power really scale as quickly the latest announcement suggested?